Okay, in this video I'm going to briefly go through how to generate plots and save them to files. So as you might expect, R has huge capability for producing different graphical outputs. Here we're just going to just look at the basics. So I've already downloaded the body brain mass text file. What we're going to do is we're going to navigate to my desktop. So I go up to miscellaneous, change working directory, navigate to the desktop, and I'm going to use the read.table function. Remember to specify header equals true, and if we take a look at the first few elements as previously, and we see the data on animal body mass and brain mass. So quickly we're going to take the log transform of the data. So we did it previously. The justification was that there was a huge range in the data, and this transformation makes the data more normal. So let's do that now. Here we're going to take the log 10. It doesn't matter. Okay. So what we're doing here is we've calculated the log of the body mass and we've assigned it to a new column in mass frame. So we'll do the same for brain mass. Notice how I just go up in the terminal to get that. Okay, so now if I do head, mass frame, we can see the extra two columns here. Okay, so we want to first of all make a histogram of the body mass, the log transform body mass. So we use the hist function, and we're going to give it the data, and just simply like that, passed into the hist function, it will produce a histogram for us. And you know, this is it's all automated. It adds column headings and plot headings and axis headings. So we can change these to suit our needs. So let's say we give it a main title, histogram of log body mass. Okay. I will give it a text label of log body mass, and we'll leave the default y-axis label, which is frequency. So you can see that we've changed the title and we've changed the x label here. Frequency was added by default. Okay, so that's a histogram. Now, what if we wish to plot log body mass versus log brain mass? Well, we'd like to use a scatter plot for that. And in R, this is given by the plot function. So let's say mass frame log body mass. So plot takes two arguments now. So previously histogram took one data argument, but for plot we're gonna give it two. Again, you should use the documentation to look at the different options available for these functions. And you can see that what this has done is it's plotted the log body mass on the x-axis, it's given it this default title, against the log brain mass here on the y-axis. So let's format that again. You can say main equals scatter plot of log body versus brain mass. We'll give it a x-axis label of log and a y-axis label and if you look again now, so we've changed those labels, and there's many different functions for plotting and changing colours and creating very nice plots. And there's actually a web page called the R Graph Gallery where you can see lots of different examples of plots that people make. So finally what we're going to do here to this plot is we're going to fit a line to the data. So this is called allometric scaling. It's a well-known phenomenon in biology. And because this linear relationship on this log scale, log scale, is known as a power law, and we're gonna fit a line to these data, just to demonstrate how easy that is now. So we're going to use the linear model function, and we're going to say that the log brain mass is explained by, this is the tilde symbol, and in words roughly it says is explained by. So this is the y, and we're going to give it the x. So I'm just going to copy and paste that and change that to body. So there I use Control V to copy and Control C to paste, like you would in Windows or in Mac. And if I do this linear model function has gone and calculated the line of best fit between log brain mass and log body mass. Okay. So actually you can get more information on that. But actually, let's assign the output of the linear model to something called fit, a variable called fit. So we can actually get more information using the summary function. And you know, you've got all this information in here. So if you had your own data, for example, and you wanted to fit a line and to see if it was significant, over here this tells us the significance of the intercept and the gradient. And really, in those those simple commands, we've done some quite sophisticated analysis. But let's also go and plot that on our existing plot. So we can do that using the AB line function. I'm going to say fit, and AB line function will draw a straight line, and it automatically knows how to handle the fit object, which is returned from this linear model. And we're going to also say call equals red. We press return, and this red line of best fit is added to the plot. So although this is very basic, you can see that you can do some quite powerful things very easily now. Okay, finally, how would we save that plot to a file? So here I'm going to save it to a PDF file. Now R has, it takes some used to getting used to the format for these graphics outputs. But basically it uses this idea of a device. So I'm going to start a PDF device, myfile.pdf. Okay. Now any plotting functions that I do will be sent to the PDF myfile. So I'm just going to go up on my keypad and I'm going to go back to my original plot. So now that plot has not been printed to the screen, it's been printed to the PDF. So I'm going to go back up and I'm going to refit the line to the data, add it to the plot, and then finally what I'm going to do is I'm going to close the device. So I close that, and we should see, oops, I'll close that one, that myfile.pdf has been created on my desktop, and there you go, a nicely formatted scatter plot with a line of best fit. And there's really a huge range of things you can do in R, and this is just a very basic introduction.